Let's talk about entropy problem solving. Here I am going to solve three problems as a series. This is the first part of the problem solving based on the entropy. Question number 1. Indicate whether each process produces an increase or decrease in the entropy of the system. The first reaction is carbon dioxide in the solid phase converted into carbon dioxide in the gas phase. For this reaction, solid become a gas, entropy increasing or the decreasing. Carbon dioxide solid to another way we called dry ice. The molecules in a solid phase arrange very closely, very organized, and there's a definite shape and definite volumes for the solid phase particle arrangement. The molecules are fixed positions, therefore the freedom of movement is very little. So when we compare the gas phase, when solid converted into gas phase, gas molecules are very far apart. Therefore no interparticle interactions, they move freely and randomly. Very high disorganized. This high degree of disorganized or movement leads to high entropy, because entropy simply we can define as the quantitative measure of the disorder or the randomness. Therefore in the solid phase, lower entropy compared to the gas phase. Gas phase, high entropy. The second reaction, calcium oxide combined with carbon dioxide to form calcium carbonate. Look at the physical state. Solid and the gas combine to form another solid. Is this process increasing entropy or decreasing entropy? The gases in the reactant side, but no gases in the product side. So this is generally number of gas molecules decreased to give the product. Gases generally have much higher entropy than the solids due to their random freedom of movements of the gas particles. When carbon dioxide reacts with calcium oxide solid to form another solid, calcium carbonate, the number of gaseous species decrease. Therefore, the randomness or the entropy is decreased. More randomness or more entropy in the reactant side with the gas phase, but gas phase become a solid, it is more organized solid phase, decreasing the entropy. Third reaction, cyclopropane and propylene are isomers that both have the formula C3H6. Isomers simply defined as they have same chemical formula but different structures. Based on the cyclopropane and propylene molecular structures given below, which of the isomers have high standard molar entropy at 25 degrees Celsius? First, let's look at the structures. This is cyclopropane. 3 carbon atoms arranged in a triangle. And this is propylene. It is an alkene. How we can compare these two molecules? Which molecule is having high standard molar entropy? Cyclopropane. It is a cyclic compound. 3 carbon atoms in a triangle. The structure is quite strained due to these angles. Angles are less than tetrahedral bond angle. Ideal tetrahedral angle is 109.5. But here the bond angle CCC bond angle is less than 109.5. Therefore, the ring strain limits the freedom of movement of the atoms. It is lower entropy. Now let's go to propylene molecule. Propylene molecule, it's an alkene. Alkene means double bond between carbon and carbon. Its result, linear or nearly linear structure, and this configuration allows more freedom for atoms to move and rotational degrees of freedom that leads to high entropy compared to the cyclopropane. Cyclopropane due to this high ring strain, limited rotation or the movement. Propylene, it's free of movement of atoms because it's nearly linear, therefore high entropy. See you all with part 2 of the entropy problem solving series.